My name is Pelumi from Pythagoras Consult. That's Pythagoras tutorial service. We are still onto our mathematics for SS1, and the topic we are going to be looking will not be contained in a single video, since it's a topic that is very wide. So now we said mathematics for SS1. But I will employ SS2 to come around. It will serve as revision for them, as the topic will usually come out in their WAEC. And I will call SS3 to equally do the same thing. So we said modular arithmetics. So SS1 and SS2 and SS3 should always look forward to SS1 work, and equally SS3 should look onto SS2 work and SS1 work. Because those are the things that you see inside your work. You don't just say, I'm not in that class. No. Because they will surely come out. Now, modular arithmetic. Modular arithmetic is basically, we call it arithmetic of remainder. It's called what? Arithmetic of remainder. What do we mean by arithmetic of remainder? We are mainly concerned about what? Remainder. Remainder that we known as what? We call it residue. So I think this spelling is correct. Residue. So sometimes we call it residue, as in it means residue means to say the leftover. So that's what we call it. And for modular arithmetic, we make use of, under modular arithmetic, we make use of some symbols. And one of the symbols that we make use of is, you see it like this, you're equal to in 3 times. That one is called congruence. So congruence is sometimes is mostly equivalent. So which sometimes is a what? Majority equal to. Then if under modular arithmetic, the addition is written mostly like this, while the subtraction something like this, as most of the time. And also the multiplication like this. And we have the division mostly, I think, like this. And you have different operations under modular arithmetic. So we need to take cognizance of all this. By the time we start going into it, then you will see more of them. So modular arithmetic, we call it arithmetic of remainder. That is what remains. Take for instance, you give us, you said module. So I will use this for module. So let's say module 6. So the residual of module 6, they are starting from 0. It could remain nothing. 1, it could remain 1. 2, 2, 3, 4, 5. But it can never remain 6 because 6 is the module. It means that it will be one shot. It will be one shot. So modular arithmetic in most form comes like this: 0, 1, 2, like that to n minus 1. So what do I mean by that's module n? So it means it gets to a stage where you just subtract 1 from your module. That is where it ends. That is where it ends. So let me still give more example that you get it clear. We have, let's say, module 8. Module 8, we have the residual of 0, 1, 2, 3, 4, 5, 6, 7. It will stop at 7. So like that, whatever module you are given, the number must not get to that module, but rather stop before the module. And that is the highest remainder you could have when you divide it by anything. Once it gets to that number, it's no more part of the remainder. So let's move further to how to give some example. Let me give example under ordinary module examples, so you see exactly what we are saying. Take for instance, someone say 5 module 4. 5 module 4. 5 module 4 is equal to, now we use our module, that's have like our base. We use it to divide our what we are given. So 4, like you say, 5 divided by 4. So you know it will be 1, of course. But what will remain is our, let's say, remainder. What will remain is our target. So it will actually remain 1. Module of what? Module of 4. So if someone tell me 1 module of 4, I know that what the person is telling me is, let me just add 1 to 4. It will give me that thing. If I want to return from here to here, I just say, let me add this one to this one. That's, it means this is exactly what they are, depending on the remainder. But that's the equivalent. So 2, let's say I have 10 module 5. 10 module 5, I divide it, that will be 2. The division, the quotient doesn't, I'm not concerned with the answer here. What I'm concerned is what remains. 0 of module what? 5. 0, it remains 0. So another one, it could be 26 module, let's say module 5. So just divide it. How many 26 can you get there? 25 in 26, that's 5. And it will remain, yes, it will remain 1. That's 1 module 5. So this is exactly how to start module. So once you get this concept, then we can now move on to the next stage. And the next stage will be talking about addition, subtraction, and multiplication, division of words, modular arithmetic. So also, before we move on to addition, subtraction, multiplication, doing this, we could use the clock system to equally solve this. So let me look at that number 1. This number 1, example 1. They said module 4. When I draw my clock will be based on module 4. I know when they say module 4, I must not exceed all my residual that I will have there. It will be what? 3. So I'll start from 0, 1, 2, 3. So stopping at 3 here tells me that this clock is for module 4 is for module 4. Now they say 5 module 4. Now let me start counting from the beginning, which is what? 0. Now 0, and we count clockwise, not anti-clockwise. So we count clockwise. Now let's go. We have 1. So I'm counting 5 times. I'm counting 5. So 1, 2, 3, 4, 5. You see, it stops at 1. So therefore, my answer will now be where it stops. 1 module 4. You see that we've gotten the same thing with this. So you could use clock. So 2, they said module 5. So the clock for module 5 should be, like I said, at n minus 1. 5 minus 1, that's 4. Should be 4. So start from 0, 1, that's 2, 3, 4. So therefore, they said I should move what? 10 times. 10 module 5. I should move 10 times. Let's move 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I stop on a 0. So therefore, my answer will be 0 module 5. It's still not the same thing. And module 5 again, for 26. For 26, so 0 is module 5. 0, 1, 2, 3, 4. So I'm moving how many times? I'm moving 26 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. So look at where I'm stopping. So it gives me what? 1 module 5. So this is how to use clock to actually get ordinary mode. That's ordinary mode. I say you use clock type. So whenever you see the highest of that clock tells you the type of module that clock reads. So addition and subtraction of modular arithmetic, and they are quite simple. We could do it ordinary and we could use our clock type. So let's see example under the addition and what? And subtraction. Let's say we are given 3 plus 5 module 4. 3 plus 5 module 4. So when we add this, it's going to give us is equals to 8 module 4. You see that this one has turned to our first example. So 8 module 4, you use your 4 to divide it. It will be 2 times. We are not concerned with that. The remainder of what? 0 module 4. So that is our answer. And I might just use the clock system. This is one way. The clock system, module 4, of course, will be 0, 1, 2, yes, just 2, 3. So we are going to stop at 3. So, but it gives us, if we add this, when you go clockwise is addition, while anti-clockwise is what? Subtraction. So let's note it. Clockwise, when you are counting clockwise, is addition, and when you are counting anti-clockwise, is subtraction under clock system. So you could use clock system or this system. Now, with this one now gives us, if you add this one, 8. So I'll move 8, since this is module 4 clock, I'll move 8 times. Addition, that's clockwisely. 1, 2, 3, 4, 5, 6, 7, 8. You see, I stop at 10, 8. So this one is still 0 mod 4. So let's see subtraction. So let's move on. Let's say we are given subtraction in this form. Give us subtraction 2 minus, let's say 2 minus 3 mod 4. 2 minus 3 mod 4. So 2 minus 3 mod 4, we can use ordinary form. And how do we go with the ordinary form? This is just like our operation that we normally have. That's like you say 2 minus 3 is equals to 4. So of course in this one we could get the big number here by, I think this thing should be clear here. I've said it before. Like if you have let's say 5 module 4, our answer would be 1 module 4. So, and I said, if it is 1 module 4, it's just like adding this your answer to this your module before you get the real. So it's still the same thing here. This one is just analogy. So it's still the same thing here to say to say these two, add it to 6 to give us exactly what's supposed to stay here. So 2 plus 4, it gives me what? 6. Add it to 4, so it will give me 6. So if I will now rewrite this equation, say 6 minus 3 module 4. So this is the rewrite of this one. I just like I'm adding this to this. So this one now will eventually give me 3 module 4. 3 module 4. So if I didn't do it this way, I could use clock form. And that my clock form will give you, like module 4 would be 0, 1, 2, 3. It stops at 3. Don't forget I said anti-clockwise. Anti-clockwise is subtraction. Anti-clockwise is what? Subtraction. So we have 2. So I'll go to 2. I go to 2. And I move what? Anti-clockwise. So 2 minus 3, I move 3 times. 1, 2, 3. You see where my answer is. So it's still giving me 3 module 4. 3 module 4. So subtraction, you move anti-clockwise, while addition, you move clockwise. So it's just of this time. Let's still look for more examples if we have.